Hey there, I'm srcmake, and in this video we are going to look at the interview question, finding the next greater element in an array. So in this video we are going to look at the problem statement. After that we are going to look at the naive solution for solving this problem. And we've got some pseudocode written here. We're not going to spend too much time on it since it's pretty simple, but we will go over the algorithm on this example array just to see how it works. After that, we'll look at the actual best solution, which unintuitively uses a stack. And we're going to spend some time on this by looking at how the stack data structure actually works for this algorithm. And then we're going to jump right into this example that I have set up. And I'm going to walk through how you would calculate the answer step by step for this example array. And it's going to be really helpful, so stick around for that. After that, we are going to quickly look at this pseudocode that I set up for how you would implement that algorithm. And then after that pseudocode, I've translated that pseudocode into the C++ program that we're going to use to test if our solution works. And the C++ is pretty much exactly the same as pseudocode, so don't be scared if you want to use another language. After that, we're just going to quickly finish off by looking at any optimizations we might need to perform, and we're going to conclude by looking at any edge cases that we might need to worry about. So all of these resources, the pseudocode and these pictures are on my website. If you need to get to this page to bookmark it or read it yourself, which I really recommend since we're not going to spend too much time on it, you can click the link below the video to get there. And while you're down there, please hit the subscribe button for this YouTube channel. Thanks. So finding the next greater element in an array. The problem statement is this. Given an array, for each element, find the next greater element to that element's right. If there's no greater element, then the value is -1. So we're given this first array, and we are tasked with generating this array down here. And the way it works is, you see this element 1 right here, we look to its right and we say, oh, 3 is greater than 1, so the next greatest element is 3, and so we mark that in this array. And then we look at element 3 and we say, oh, so 3, if we look right, that's 2. 2 is not greater than 3, so we have to keep looking right. 5 is greater than 3, so the next greatest element for this element 3 is 5. We mark that in the array, and we keep doing that. For element 5 over here, it's a little bit interesting because if we look to 5's right, there's no greater element, and so we have to mark that as -1. And it's a pretty simple question. So the naive algorithm is basically what we just did. For each element, look to its right, and it's basically nested for loops. We will cycle through each element, and then we will look to its right to see if we can find the next greatest element or not. And so what that would look like is we go through each one of these elements and we look to its right and we keep looking right until we find the next greatest element. And I'm not going to spend too much time going into it. So the time complexity for that is order n squared because potentially every element has to look at every element on its right. The space complexity is order 1 because we're not really using any extra space for anything. Now, this is actually pretty easy to code, the naive solution. It should take only really a couple of minutes if you've got everything set up. So I would try to implement this naive solution just to get working code in an interview, but that's not going to get you good points with the interviewer because they want to see something a bit quicker. So the quicker solution, which turns out to be the best one, is using a stack. Now in this algorithm, the way we use a stack is that the stack stores the index of elements that have not calculated their next greatest elements yet. And every time we visit an element, we check if its value is greater than the element on the top of the stack. I know this sounds a little vague right now, but this example is really going to clear it up, so let's do it right now. So here's the example. What we're going to do is we're going to go through each one of these elements in the array one by one, and let's start out with this one. So we look at this element, and there's nothing on the stack, so what do? We put it on top of the stack. Now, pro tip for life, you don't have to just work with the elements themselves, you can work with indices, and in this case, we do need to work with indices. So we're going to put index 0 on top of the stack. Next, we're going to look at the next element, and it's element 3. So we say here, now that we have something on the stack, is this element 3 greater than the element at the top of the stack? So we say the element at the top of the stack is a of index 1. Actually, it's of a of index 0, which turns out to be 1. 3 is greater than 1, so here's what we do. We mark index 0 with this 3, since that's the next greater element. We pop the top of the stack, which means we remove this 3. And then, since there's nothing left in the stack, we are going to push this index, index 1, on top of the stack. So that's it. We processed element 0. That's how that processing works. But now we have to continue on. So we're looking at this next element. It's 2. Is 2 greater than the element of the top of the stack, which is at index 1, which happens to be 3? 2 is not greater than 3. So what we do is we put index 2 on top of the stack, and we move on. So the next element is element 6. Is element 6 greater than the element at the top of the stack, which happens to be at index 2, because index 2 is at the top of the stack? A of 2 evaluates to 2. 6 is greater than 2. So what we do is we say, okay, 6 is marked in our return array right here. And then we are going to pop the top of the stack. And then, you know what? Since 6 did such a good job, we're going to continue checking. So we're going to check the top of the stack again. Is 6 greater than the element of the top of the stack, which in this case is at index 1? And 6 is greater than 3, so we are also going to mark this index in the return array as 6 is the value for the next greatest element. We're going to pop the top of the stack, so we're going to get rid of 1. And then 6 did its job, there's nothing left on the stack, so we push index 3 on top of the stack, and then we continue on. So next we've got index 4, element 4. It's not greater than 6, so we're just going to push index 4 on top of the stack. Next, we're going to look at element 5. Element 5 is greater than 4, so we're going to do our usual thing. We are going to push, we're not going to push anything. We are going to set this in the return array as the next greatest element of this index is 4. Then we are going to push this index off the stack, and we said, you know what, 5 did such a great job, we're going to check it for the next top of the stack. So the next top of the stack is at index 3, which is 6. 5 is not greater than 3, so we can't do anything. 5 did its job, so now we are going to push index 5 on top of the stack. We're going to look at this last element, 2. 2 is not greater than 5, so we are going to push index 6 to the top of the stack. So now we've pretty much went through every single element in the array, and now we've got some leftovers in the stack. These leftovers, unfortunately, do not have a next greatest element, and so what we do is we go through each one of them, and their values in the return array are going to be -1. So we look at the top of the stack, it's index 6. We're going to mark that next greatest value as -1. We're going to pop the top of the stack. We're going to look at the top of the stack again. We're going to see index 5. We're going to mark that as -1, pop the top of the stack. Then we are going to look at the top of the stack. It's index 3. We're going to mark that as -1. We're going to pop the top of the stack. And we have no more elements in the stack, and so we're done. And so the return array, which is a little bit hard to see, I'm sorry, but the return array is this, which I'm not going to do it in this video, but if you visually inspect, it's going to be the correct answer. So just to recap what that algorithm was we go through each one of the elements once. If there's nothing on the stack, or if the top the element we're processing is not greater than the top of the stack, we push it onto the stack, and we keep going like that. And then at the end, everything that's left over on the stack didn't have a next greater element, so we mark them as -1. So that is the algorithm. Let's look at the pseudocode to see how it works. And this pseudocode is right here. So we've got a function called next greatest element. It's going to return an array, and you can input an array A in it. We initialize the return array, and we create our stack, basically what we did right here. So that's just some setup. Then we go through each element in the array, which is what we were doing before. And we've got this while loop that says if there's something on top of the stack, then we check if the element we're currently on is better than that one. If it is greater, then we mark the answer array and we pop that off the stack. And if it's not greater, then we have to stop because it obviously wasn't the best. And after we're done, we push the element that we were working on onto the stack. And we keep going until finally we've got to do our cleanup where anything that's left in the stack didn't have a next greater element. And so we have to mark it with -1 and pop it off the stack. Then we return that answer. So that was actually pretty simple, and I think I went through it pretty well. So the time complexity for that solution is order n, since we visit each element in the array only once. The space complexity, however, is also order n, because at worst, we have to push every single element on top of the stack. I've got this code right here that we're going to run right now. I'm srcmake, so we're going to type make because we like make files. And if we make this a little bigger so you can see, and we kind of compare it right here, we've got, can you see really? Yeah, you can see right now. So we've got two examples. This was the example from up top. This is 132, blah, blah, blah. And we can see that our code matched up to what our algorithm did, and that should be the correct solution. So you can find that code on GitHub, by the way. If you click this link right here, then you'll come to this GitHub page where I do a lot of other interview questions. And this one is next greatest element. And main.cpp has this code if you want to find the full working source code. Because I do recommend you try to code this yourself afterward and make sure you know what you're doing. Because coding is actually the harder part. Well, as long as you know the algorithm, it should be good too. So optimizations. The one optimization that we could do is we can calculate the array in place. So in the pseudocode, and for this example, I had a return array that was separate from the initial array, but we didn't really need to do that. If we really wanted, we could just like overwrite this array right here when we were doing the calculations, and that's probably better because it doesn't take up any extra space. I mean, the stack still takes up space, so the space complexity is still order n, but it's just a little bit more efficient if you can do that. And any edge cases, so for the algorithms we use today in the pseudocode that I wrote, there aren't really any edge cases we have to worry about, but an edge case you might have to worry about that it's good to think about anyway is that if you have an empty array, you need to make sure that you handle it. And it's always good to think about edge cases because the interviewer wants to know that your code is bulletproof and you're covering everything, and it's not some like bad solution that didn't cover what it needed to. So that was it. If you like this video, please subscribe below. Like this video, leave a comment. If you've got an interview question you want me to answer or do a video on, feel free to leave a comment on that. Follow on social media, including Twitter, and thank you for watching. Good luck.